Good evening, Titans. This is Mr. Simpson, and today we're going to talk about how do we solve an inequality by using addition or subtraction. And so let's just get after it. All right, the core concept here is, in words, the addition property of inequality is adding the same number to each side of an inequality produces an equivalent inequality. So for example, if a negative 3 is less than 2, and we add 4 to each side, well, negative 3 plus 4 is 1, 2 plus 4 is 6, so 1 is less than 6. It's still a true inequality. And if negative 3 is greater than or equal to a negative 10, and we add 3 to both sides, we get 0 is greater than or equal to a negative 7, which again is a true inequality. And so we're going to apply this to solving inequalities. So if we look at this, we have b minus 2 is greater than a negative 9. Well, this first one, if I want to get rid of the negative 2, I'm just going to add 2 to each side, just like we've been doing when we've solved equations. So we get b, the negative 2 and the positive 2 cancel out, is greater than negative 9 plus 2. Different signs subtract. Take the sign of the larger number, your sum will be exact. And now we want to graph this solution because if b is greater than a negative 7, that's a lot of numbers to write down. So we put this on a number line. And what I would like you to do, if you have to create your own number line, I like to go in order. So I have negative 7, then a negative 8, and negative 6. So I want to go in order from least to greatest. So with negative numbers, it goes negative 8, negative 7, negative 6. It's greater than, so I know it's just an open circle, and then it's shaded to the right. Okay. Now I'm going to do number 2, and we'll slide this one over here. So I have m minus 3 is less than or equal to 5. Now again, we just go ahead and solve for m by adding 3 to both sides. Again, the negative 3 and the positive 3 cancel out, so I get m is less than or equal to 8. And now I graph this. So I like to put the 8 in the middle, and then I surround it by 7 and 9. So I have 7, 8, 9. Now this is an equal to, so that means I have to color that dot in, and then it's to the left. So I'm going to shade to the left then. All right. Now I'm going to go ahead and erase these before I do number 3. Now if we look at number 3, again, now we have 1/4 is greater than y minus 1/4. And so to get the y by itself, I have to add 1/4 to each side. So I'm going to add 1/4 to each side. The good news is these all already have a common denominator. 1/4 plus 1/4 is 2/4 is greater than y. And I like to reduce the 2/4 to 1/2. But now if we're going to graph this, we want to make sure we rewrite this so the variable is on the left side. So I'm going to rewrite it so the y is on the left, the 1/2 is on the right, and now since the alligator mouth is eating the 1/2, when I rewrite it, I have to make sure the alligator mouth is eating the 1/2. And now we go ahead and we graph this. And when we graph fractions or decimals, I like to put the two whole numbers or integers that surround the fraction. In this case, now I'll put the fraction in. Now it's open. And now that we have it written in this order, it's going to be y is less than, so I shade to the left. Now I'd like you to try this one. So pause the video for a moment, give it a shot, and then I'll reveal the answer. All right, welcome back. And again, if it's x minus 6, to get the x by itself, I'm going to add 6 to each side. Minus 6 plus 6 cancel out, so I get x is greater than or equal to, and negative 10 plus 6 is a negative 4. And then you would graph that. And so again, I go negative 5, negative 4, negative 3 in order from least to greatest, going from left to right. It's greater than or equal to, so I have to color it in because of the equal to, and then greater than is to the right. So now, the second core concept is the subtraction property. And again, we could just tie this right in with the addition property, and just instead of subtracting, we're adding a negative to it, which is what I which is how I like to think of it. Instead of using subtraction, just think of it as that you're adding a negative number to each side, all right? And again, so if I'm adding a negative 5 to each side, in this first example here, negative 3 plus negative 5 would be a negative 8. It's still less than or equal to a negative 1/4, and so on. So again, if we just look at this core concept, and here's the first one. This is a positive 8, so to get rid of a positive 8, I'm going to add a negative 8 to each side. Again, I just like to think of it as adding a negative 8 instead of subtracting. It just makes it easier in my mind. So the 8 and the negative 8 go away, and I get y is less than or equal to. Here, the signs are different, so I subtract, and I take the sign of the larger number, my sum will be exact. So I have y is less than or equal to a negative 3, and now I graph that. So I have negative 4, negative 3, negative 2. I'm going to have it closed at a negative 3, and then shaded to the left. This next one, again, I'm solving for m, so the m is on the right this time, so I'm going to subtract 1.4, add a negative 1/4 to each side. And when I do that, and I have negative 8 and negative 1.4, I go ahead and I add, so that's a negative 9.4, because I add and keep, is less than m. Remember, I still want to rewrite it, so it's written as m, and then negative 9.4 on the right. And again, I don't want to upset the alligator. This time the alligator is eating the m, so I want to make sure I rewrite it and have the alligator eating the m. So now I have a negative 9.4, so I'm going to have negative 10 and negative 9. And then the negative 10, negative 9, negative 9.4 would be about right here. And again, it's greater than, so it's an open circle this time and shaded to the right. All right, now you try. All right, welcome back. And in this first one, you'd have k is less than or equal to a negative 8. And then to graph it, you'd have negative 9, negative 8, negative 7. It'd be closed at negative 8 and shaded to the left because it's less than or equal to. Here I'd subtract 1/6 from each side, or add a negative 1/6 to each side, and I get 4/6 is less than or equal to z. That would be the same as 2/3 is less than or equal to z. Then I want to rewrite it, so it's going to be z is greater than or equal to 2/3. And then again, I would graph this. So 2/3 lies between 0 and 1. So 2/3 is about here. Again, it's greater than or equal to, so I color it in. I shade it to the right. And this last one, we'd add a negative 0.7 to each side. And since the signs are the same, we'd have p is greater than. Add those, be a negative 3.0. And then we graph that. And again, we have negative 4, negative 3, negative 2. It'd be open and shaded to the right. All right, and then this last one is just a word problem. So a circuit overloads at 1800 watts of electricity. You plug a microwave oven that uses 1100 watts of electricity into the circuit. Write and solve an inequality that represents how many watts you can add to circuit without overloading the circuit. Well, it says it overloads at 1800, so we better have less than 1800 on there because we don't want it to overload. And we already put 1100 on. Oops. So now we have x plus 1100 is less than 1800. If we solve this, we would subtract the 1100 from each side, and we get x is less than 700 watts. So in addition to the microwave oven, which of the following appliances can you plug into the circuit at the same time without overloading the circuit? And so if we look at this, the only one we can't do is the hot plate. Because if we plug in the clock radio, and we plug in the blender, and we plug in the toaster, all those, even if we plug them, all of them in, it doesn't add up to more than 700. And it just has to be less than 700. So we have to take away the hot plate. If we do that, we're going to blow the fuse. All the others we can go ahead and do. All right? So that's solving inequalities using one step. Have a great night, and we'll see you tomorrow.